this gets harder is people immediately try to go for the kill. Like, you know that part C is coming. When you see a differential equation, you know you're going to have to separate variables and generate an equation. They want you to do a little analysis beforehand. I think this one was worth 2 points at this point. I think this is 2 points. Yeah. So then the next one asks you, find the second derivative. Is there any special trick to finding the second derivative?
Find the first derivative first.
Yeah, and do they give us the first derivative? Yeah, they tell us that dw dt is equal to, what was it, 1 over 25 times w minus 300? What's the only thing you should do first before you differentiate? What's the only thing you should do before you differentiate? There's no, we're differentiating, we're not integrating, so no separation yet. Distribute, literally just distribute first. dw dt is equal to 1 over 25w minus 12. If you do the second derivative, if you now do the second derivative, what do you end up with? 1 over 25. That is the second derivative. It's asking you, based on this number, can you tell me if our original estimate for 1/4 is an underestimate or overestimate? So that has to do with the what of the curve, the concavity. This number is always what? Positive. This is greater than 0, which implies concave what? Up. And concave up implies all tangent lines are what? Are below. So this is a underestimate. Because concave up means like this. All tangent lines are below the curve. And I think this one was 2 points as well. This is 2 points as well, I think. Yeah. So what does part C ask us to do? Oh, it's part C. It's what we thought it was going to ask us the entire time. It's what it's going to ask us the entire time. Nice. So how many points is this worth? Well, the first two were worth 2 each. So how much is this one worth?
Nothing if I don't separate.
Nothing if you don't separate the variables. All free response questions are worth 9 points. What's 9 minus 2 minus 2? 5. They're all worth 9 points. There are 6 free response questions. It's 54 points total for the free response and 54 for the multiple choice, although there are only 45 multiple choice questions. So do you know what they do with your multiple choice score? They multiply it by?
I'm sorry.
What do you multiply 45 by to get to 54? Have this. What do you have to do first, Lena? Say it one more time.
Separate.
Yeah, so we divide by w minus 300 and you end up with dw over w minus 300 is equal to 1/25th dt. Excitement. And then what do you do? One word? Integrate. So you get ln of w minus 300 equals 1/25th t plus some constant. Exciting. Now you need to isolate actually what? You need to isolate w, so it's going to be e to the what power? 1/25th t plus c equals w minus 300. Side note, why are we allowed to drop the absolute value right here? It's going to be positive. How do you know it's going to be positive? No. It's okay. Look at what you're plugging in. It's w minus 300. What's the initial value of w? 1400. And we already showed it only goes what? Up. So it's going to be positive. So they do that thing where you make it a e to the 1/25th t equals w minus 300. But what's your initial condition? When t is 0, what's w? 1400. So when you plug that in, you know, with a e to the 0 is equal to 1400 minus 300. So what does a equal? 1100. So what do you get for an equation? You get 1100 e to the 1/25th t is equal to w minus. So w in terms of t is equal to 1100 e to the 1/25th t 300.
What was that thing with the, why did they bring that A?
They just say this. So the side note here is, I've just done this so many times, I'll try to slow it down. E to the c, e to the 1/25th t, right? This is just a constant, right? So they just call it a.
Okay, so you wouldn't...
You would get the same exact thing if you did it out. This is just an easier way to notarize it. It's just an easier way to notarize it. It's just much easier. And that's 5 points. And here's the thing. How long, if you crank through this, you're going to do this maybe, even if you did it with twice the amount of time, that was 3 minutes total. 5 points in 3 minutes. Hallelujah. That's awesome. When you see slope fields and when you see differential equations, you're like, yes, points. Free points are awesome. You have to know what the Taylor series for sine x about 0 is. You have to know what it is. Lena, what is it? X to the, yep. Exactly, that's sine x, right? So then they're like, they are holding you by the hand on this one. Then they're like, now substitute in x squared. So you're like, okay, yes, test. I will do what you say. X squared minus x to the 6th, 3 factorial. I wonder what the most common error would be. I think people would just substitute, like, powers wrong. Yeah, they'd add the exponents or just like square them, like x to the 36th or something. Who knows? And then for b, I think they ask you like the same thing, but for pretty much the same thing. So you have to write cosine, and then they say build the new one, right? So who can tell me cosine? What's cosine of x equal to? 1 minus plus. Ah, you got to skip it. Ah, x to the 4th. I got that wrong. Over minus 6 factorial. And then they say build it together, right? So you need to have sine of x squared plus cosine of x. You're putting them together. And they want the first 4 non-zero terms. This is where I already shared this with some of the class when I came in. This is where the super embarrassing math error I made last class came into play. You have to be super careful about this because when they say the first 4 terms, you have to make sure you combine like terms or you won't get the point on this. So the first term is definitely 1. Yay, you just got rid of that one. That's nice, right? But then the next term you have to take care of is the squareds. If you add those together, what is x squared minus x squared over 2? It's just x squared over 2, exactly. And then the next power that you see, what's the next power you see? You see x to the 4th, so you get x to the 4th over 4 factorial. But then you need the next term, and that's going to be this and this. And this is where I was terrible at math. Just to show you my glory, I did I did this. And I was like, oh, well, that's 720 and that's 6, so that must be x to the 6th over 726. Yeah, don't do that. Don't do that. What do you need to subtract fractions? You need a common denominator, right? So in order to build a common denominator on this, you just end up with, as far as I remember, you end up with minus like 121 x to the 6th over 720. But that's just 6 factorial. Nice. So fantastic. You did that nicely. I mean, I see it. I see this right here, and I see this right there. So what's left? Negative 121. Negative 121 is what's left. Does everybody see that right there? When you guys did this on a quiz, you kind of fell for the bait, and instead of actually using the Taylor polynomial to figure out what that was, what did you guys do instead when I asked you for the 6th derivative and evaluated it at 0? What did you do? You kept on taking derivatives. I'm like, no, don't do that. Because if you try taking derivatives, it just gets bad. It gets real bad. You have to remember this, or there's no other way to do it. So on this one, it says, let P sub 4 of x be the 4th degree Taylor polynomial of f about 0. Using information from the graph above, show that this is less than 3,000. What is this statement right here, the one on the left? What does this represent? The error bound. This is the max error. You want to show that the max error is less than 1 over 3,000? There's something you just have to remember. There's something you have to remember, which is the max error is less than or equal to m over n plus 1 factorial x minus a to the n plus 1. And what does m equal? M is greater than or equal to f of n plus 1 centered at the a value. You have to remember this. How many people have ever acted before or been in an English class where you have to memorize a speech? This doesn't even compare to the stuff in terms of complexity that you've been forced to memorize. Did I get it wrong? Oh, I think it's what it should be A up here. It's what it's centered around. That's what it's centered around. No, it is X. I'm sorry, it is X. You're absolutely right. It is X. It is X. So when you're doing this, you go back up to the graph here and you're like, oh, I finally get to use this graph, which I think I clipped in, didn't I? On this graph right here, when you go to 1/4, 1/4 is right here. So you go up here, your tendency might be to try to estimate what that value is. Should you do that? No. You can make that as big as you want as long as your final product is still less than 1 over 3,000. You want it to be less than 1 over 3,000. So you can make this as big as you reasonably want, but it better still be less than 1 over 3,000. So you know that this value right here, what is it definitely less than? 40. So call it basically, quote unquote, round it up to what? 40. Round it up to 40, and then you hope that it's still less than 1 over 3,000. So when you plug this in, you're saying the m value is going to be 40. What's the n value in this scenario? What's the n value? 4. So when you plug it into this statement, what do you get? You get 40 over 4 plus 1 factorial, 1/4 minus, what is the polynomial centered around on this one? 0, so it's minus 0, which makes you happy because you don't want to have to exponentiate horrible fractions. To the what power? 5th. So then you take this, and this is not a calculator question, so you need to simplify it by hand, which you totally can do. You have 40 over 120 times 1/4 to the 5th. What's 40 over 120? 1/3 times 1 over what? What's 4 to the 5th? Well, it's big, right? It's 256 times 4. It's 250, 10, 20, 1024, right? 1020. We should know that, shouldn't we? 1024. It's how many gigabytes are in a terabyte. It's how many megabytes are in a gigabyte. How many bytes are in a megabyte.
It's equal to.
So if you do this, you just do it out. That comes out to be 1 over 3072 when you do it out. But here's the thing. 1,372, you just showed that this right here, is less than or equal to 1 over 3072. But how does that fraction compare to this one? It's smaller. So therefore, it is less than 1 over 3,000. When you look at the work on this, when you see the answer key for this, it's kind of infuriating because it's like, wow, I didn't do that much work. They did so much less work. This is the super, 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 super condensed version. Like, look at that. They did the exact same thing we did. They wrote it out in the super condensed version. Just because it looks clean doesn't mean it was really easy to find it. Does that vaguely make sense? Kinda? Maybe? Sorta?